I am Yanis at Batilier and I'm going to talk about the introduction to circle graph. Did you know that the fundamental unit of a circle graph, the circle, was once a god? In 5th century BCE, Greek philosopher Empedocles labeled it as such. Amazing, right? For the technically inclined among us, circles are the most source of the most practical inventions such as the wheel. But to the Greeks, they are emblems of infinity. Beginning with the definition of a circle graph, we'll move on to discussing its importance before delving deeply into its utilization. A circle graph, also known as a pie chart, is a type of graph used to visually represent data. It is made up of slices that represent data, or slice of each data point concerning the entire. Slices are typically displayed clockwise, representing the numerical progression of data points. A circle graph can be used to show the relative parts of a whole, such as the percentage of a population that belongs to each age group. So, Kainkoy will give more about the introduction to circle graph.
Thank you, Mr. Batelier. So William Playfair is the one who created circle graphs or pie charts in 1801. Two of these graphs, the first two pie charts, can be found in his book, Commercial and Political Atlas and Statistical Breviary. Playfair displayed an example that features several circle graphs. One of those maps show the dimensions of the Turkish Empire, which existed before 1789 and was spread across Asia, Europe, and Africa. At first, not many people used this invention. The circle graph may not have been created by Florence Nightingale, but she improved it to make it more readable, which encouraged its widespread use even today. In fact, Nightingale modified the circle graph by making the length of the wedges variable rather than their width. And the French engineer Charles Joseph Menard also used pie charts in 1858. He depicted the cattle that were shipped from all over France to Paris on a map from 1858 using circle graphs. For the circle graphs description, let us have Ms. Daniel.
Hi, I'm Danica Elijah A. Danielle, and I will be discussing the description of a circle graph. So what does a circle graph show? A circle graph is an effective visual representation of a set of data. It is best used when the number of data points are small or easy to work with. And there are different types of circle graphs that shows all the same information but with a slightly different visual appeal. Circle graph is a way of summarizing a set of nominal data or displaying the different values of the given variables. An example is a percentage distribution. This type of chart is a circle divided into a series of segments, which each segment represents a particular category. When do we use a circle graph? We use circle graph to compare the parts of a whole. Circle graph represents data visually in the same proportion of a numerical data in a table. The area of each sector in a circle graph is in the same proportion to the whole circle, as each item is to the total value in a table. And that is all for the description. Moving on to the next topic, definition of terms will be discussed by Jack Chris Paradero.
Hi, my name is Jack Chris Paradero, and yes, we will be discussing some terminologies before we proceed with the actual problem of the circle graph. Now, to begin with, let's define the circle graph itself. When we talk about the circle graph, this is a circular representation of data with different slices representing a percentage of the total. Each wedge in the circle is proportional to the quantity it means. Alright, that's it. Second is the graph. When we talk about a graph, can be defined as a pictorial representation or a diagram that represents the data or values in an organized manner. The points on the graph often represent the relationship between two or more things. Okay. Third is we have the portion. When we talk about a portion, this is a part of a whole, and a portion of the circumference, which is also known as the arc of the circle, and the two radii of the circle meet at both endpoints of the arc, forming a sector. Now, speaking of that, when we talk about a sector is said to be a part of a circle, which is made of the arc of the circle along with its two radii. Next is we have statistics. When we talk about the statistics, this is the study and manipulation of data, including ways to gather, review, analyze, and draw conclusions from data. Next to that is we have the categorical variable. When we talk about the categorical variable, this is sometimes called a nominal variable. This is one that has two or more categories, but there is no intrinsic ordering to the categories. That's it. Next is, if we talk about categorical, let's also talk about the numerical variable, in which this is the numeric variable and also called a quantitative variable. It's a quantifiable characteristic whose values are numbers, exact numbers which are codes standing up for categories. So numeric variables may be either continuous or discrete. That is for the numerical variable. Now let's talk about the percentage. So for the percentage itself, this is a rate, a number, or even an amount in each 100. Any proportion or share in relation to a whole. That is a percentage. Next is a whole number. This is very common to us, of course. Whole numbers are a collection of all the basic counting numbers and zero, meaning all real numbers and zeros. That is considered to be whole number. In mathematics, counting numbers are called natural numbers. So we can define the whole number as a collection of all natural numbers and zeros. Whole numbers also include all positive integers along with the zero. Alright, now lastly is we have the central angle, the very core among all. Of course, the central angle is formed at the center of a circle due to the intersection of any two radii within the circle. As stated, a central angle in geometry is one whose vertex forms at the center of the circle, with two radii forming its arms that intersect the circle at two different points. Alright, so those are actually the terminologies that we actually need to define before we engage in the specific topic, the circle graph. The next part will be the steps and procedures. Let's check.
Hi everyone, so before giving you some sample problems, I am Rachel Ui and I am here with Ms. Syra Shane Orsal to give and discuss to you what are the steps and procedures in making a pie or circle graph. So step 1 is we need to draw a circle. Step 2, put your data in a table like this one. So step 3, we need to divide each value to the total frequency and multiply it by 100% to get the total percent of each value using this formula. So the step 4 will be discussed by Ms. Orsal.
Thank you, Ms. Uy. So now let's proceed to step 4, which is to multiply the total percent in every value to 360 with the given formula. And lastly, it is for us to determine or figure out the degrees and label each slice. And that is the whole procedure on how to make a pie or circle graph.
Hello everyone, I am Abigail Colleen Mata and I am going to present our sample problems. I am going to present today our sample problems. A poll was taken to know the modes of transportation due the college students in the University of Cebu Banilad campus has. Each student voted only once. 68% of the students commute going to school, 10% of the students walk, and the rest of the population have their own personal service. So, how many percent of the college students in the University of Cebu Banilad campus have their own personal services? So now, let us make use of the data that we have. What is the mode of transport do most of the college students in the University of Cebu Banilad campus have? And how many percent of the college students walk going to the university? Now, let us find the central angle of each category to be able to illustrate the poll data using a circular graph. And that's it for our sample problems. Let's now have Ms. May Saison to discuss the solutions to the mentioned problems.
Hi, I'm May Saison, and I will be discussing the solutions. So, moving on to the solution. Let's solve the first problem. How many percent of college students in UCB have personal services? So, let A be the percentage of college students who commute, let B be the percentage of college students who walk, and let C be the remaining college students who have personal services. So for A, we have 68%, for B, we have 10%, and for C, we have an unknown percentage, and that is what we are looking for. So we use the mixed equation. 100% minus the sum of A plus B. Substitute 100% minus the sum of 68% plus 10. We get 78%, and then we subtract it from 100%, giving us 22% for C, or for the percentage of students who have personal services. So in conclusion, the answer for this problem is that the percentage of students who have personal services is 22%. Now for the second problem, using the given data, we have to find the mode of transport commonly used among the students in UCB. So we should remember again the values we have assigned, A, B, and C. So A is 68%, B is 10%, C is 22% as how we solved it in the first problem. So we only need to arrange the values in ascending order to find the highest percentage. So for the first order, we have 10%, which is the percentage of students who walk. Next is 22%, percentage of students who have personal services. And the last or highest percentage, 68%, which is the percentage of students who commute. So as we identify, 68% is the highest percentage, making this in conclusion that most students' mode of transportation is commuting. Third problem, we have to find out the percentage of students who walk. And this is only by identifying them through the set of values given to us. So we have A, 68%, B, 10%, and C, 22%. And as we remember, the percentage of people who choose to walk is in B, which refers to 10%. So in conclusion, the percentage of people who choose to walk to the university is 10%. For the last problem, we have to find the central angle of each category to illustrate the Paul data and better illustrate the pie graph. So we need to remember how we assign the values for easier referencing. So the equation goes as angle of category equals category frequency over total frequency times 100% parentheses times 360 degrees. Now it is 360 degrees. We multiply it to 360 degrees because a pie chart is basically a circle. And a circle's measurement of degree is 360 degrees. The calculation of category frequency over total frequency times 100% is just ultimately finding the percentage frequency. So we could shorten the equation to percentage of category times 100% parentheses times 360 degrees. However, the given values are already percentages. Therefore, there is no need for us to do the first half of the equation. Since our values are already in percentage, 68%, 10%, and 22%, we only have to divide them over 100% times 360 degrees to find the angle of category. So first we do A, which is 68%, referring to the percentage of people who commute. We have angle of category equals 68% over 100% times 360 degrees. We cancel the percentage symbols to show that they are being canceled. And then after we cancel, we solve them first. 68 over 100, we have 0.68. Then multiply them to 360 degrees. We get 244.8 degrees. We do the same thing to the other set of values. B, 10%. Just substitute the values in these same equations until you get 0.10. Then multiply to 360 degrees. And you get 36 degrees for the 10% of people who choose to walk. Then for the 22% of people who choose to have their personal services, you just have to substitute the values into the same equation until you get 0.22 times 360 degrees, and then until you get 79.2 degrees as the answer for your 22% of people or students who have personal services. In conclusion, the central angles in each category are as follows: 244.8 degrees for the category of students who commute, 36 degrees of the category for students who walk, and 79.2 degrees for the category of students who have personal services. That's all, and we will be moving on to the interpretation or answer by Carmeline Barangan.
Hi, I'm Carmen Barangan, and today I'm going to discuss or interpret the answer to the given problem. A poll was taken to know what modes of transportation do college students at the University of Manila campus has, and each student voted only once. 68% of the students commute, 10% walk, and the rest of the population has personal service. In order to get the percentage of the remaining or the students who uses personal service, we use the addition and subtraction to find the percentage of college students in UC Manila who have personal services. Let's say we use A, where we let A be the 68% of the student of UC Manila commutes, and let B the 10% as the students of UC Manila walks, and C will be the remaining or the unknown that we need to get the percentage that is lacking on the problem. So we're looking at the 100% of the graph. We know that 100% minus A plus B equals C, the unknown. Substituting the value for A and B, we get that the 100% minus 68 plus 10% equals unknown. We let 100% minus 78% equals C, and we get 22% as a C, which is the unknown, or the 20%, or therefore 20% are the students who have personal services in UC Manila campus. To get this in graph, a circle graph, also known as a pie chart, is a visual representation of data that shows how much each category contributes to the whole. In a circle graph, the whole circle represents 100%, and each category is represented by a slice of the circle, the size of which corresponds to the percentage of that category. And the calculation of the central angle of each category, we need to use a formula that keeps the percentage of each category and converts it into an angle measurement. The formula is angle of category equals percentage of category, or the total percentage, times 360. In this case, we were given the percentages of each category, so we can plug those values into the formula. For example, to find the central angle of the category A, which is the percentage of college students who commute, we use the formula like angle of A is equals 68% divided by 100% times 360, and angle of B is equals to 0.68 times 360. Angle of A equals 244.8 degrees Celsius. So the central angle of the category A is 244.8 degrees. We can use the same formula to find the central angles of the other categories, B and C, using their respective percentages. Once we have all the three central angles, we can draw the circle graph by dividing the circle into 3 slices, with each slice representing one of the categories and its corresponding central angle. The calculation provided below is the process of finding the central angle of each category in the pie chart given the percentage of each category. The total degrees in a circle is 360, so to find the central angle of each category in the pie chart, given the percentage of each category, the total degrees in a circle is 360 degree. So to find, for example, if a category represents 10% of the whole pie chart, then its central angle is 10% times 360 angle equals 36 angle. In the given example, the category of students who commute represents 60% of the whole pie chart. So its central angle is 60% times 360 angle equals 244.8 the angle or degree. The category of students who have personal services represents the 22% of the whole pie chart. So its central angle is 22% times 360 degree equals 79.2 degree. Then to check if the central angles of all categories sum to 360 degree, you add them up. In this case, 244 or 244.8 degrees plus 36 degrees plus 79 or 79.2 degree equals 360. That's the whole chart. So the calculation is correct, and the central angles of all categories do add up to 360. So below are the calculation for the angles.
Hello everyone, I'm Christine and I'm here to discuss the conclusion. It has been shown that a circle graph, also referred to as a pie chart, is extremely helpful, visually simpler than any other type of graph, and is simple for individuals to use. It is utilized to help organize and showcase data as a percentage of a whole. Aside from that, the circle graph allows people to see the data comparison at a glance and make an instant analysis, regardless of whether that one portion of the total is small or large. Consequently, when conducting a survey, we can use circle graphs to clearly indicate the preferences of respondents, allowing researchers to make an immediate analysis. Thank you for listening, and here's Ms. Abeliar for the references.
These are the references that you can see in our discussion regarding the topic circle graph.